Ukraine has discovered the secret to destroying billion-dollar equipment. Right at this moment, in hundreds of hidden workshops, machines that look like toys are being produced on an industrial scale, and they are rewriting the rules of global air power. But here's what will really surprise you. These machines not only fly themselves, but they also think for themselves. They learn, adapt, and make lethal decisions without any human interference. And all this was born from a country that just 10 years ago was selling off its own air force as scrap. But how did a nation that couldn't even keep its own planes flying create the technology that's putting the world's biggest military powers into a panic? And what will happen when these technologies spread worldwide? But to understand how we got here, we need to start in 1991, when Ukraine gained its independence with the collapse of the Soviet Union, inheriting something impressive: the third largest air force in the world. We're talking about approximately 1,100 military aircraft, including Su-27 flanker interceptor fighters, MiG-29 Fokker multirole fighters, Su-24 Fencer tactical bombers, and even two 160 Blackjack strategic bombers. To give you an idea of the scale of this inheritance, Ukraine had more military aircraft than the United Kingdom, France, and Germany combined. In theory, it was a potential air superpower. In practice, however, it was like inheriting a whole collection of Formula One cars without money for fuel, much less for maintenance. The problem started immediately. Maintaining a fleet of that size cost a fortune the country simply didn't have. The Ukrainian economy was collapsing, infrastructure needed rebuilding, and priorities were elsewhere. Moreover, international agreements like the Budapest Memorandum encouraged disarmament in exchange for security guarantees which, as we know today, were worthless. The result was a gradual but relentless process of dismantling. Aircraft were sold to other countries, others were simply scrapped, and many were abandoned in hangars without maintenance. Parts were taken from some to keep others flying, a process known as cannibalization. By 2014, only about 125 aircraft remained airworthy, and even those operated with serious limitations. It's important to understand this was not a deliberate process of negligence, but a brutal economic reality. Ukraine simply didn't have the resources to keep one of the largest air forces in the world functioning properly. In 2014, Ukraine was brutally awakened from its relative calm. The annexation of Crimea and the start of conflicts in the east dramatically revealed the National Air Force's limitations. During the first months of fighting in Donbass, the country lost approximately 20 aircraft between combat losses and accidents related to lack of proper maintenance. But it was exactly from this crisis that innovation was born. With few resources and urgent needs, Ukrainian technicians began developing creative solutions now studied in military academies around the world. Abandoned hangars were transformed into improvised repair workshops where civilian and military mechanics worked side by side. One of the most remarkable stories from this period involves restoring a Su-27 using parts adapted from a Lada car. The car's brake system was modified to work on the aircraft's landing gear. This kind of adaptation, which might seem like desperate improvisation, actually showed an impressive level of ingenuity and technical knowledge. More importantly, it was during this period that the first serious experiments with unmanned aerial vehicles began. Initially, these were adaptations of commercial equipment, aerial photography drones modified for military reconnaissance. What started as an emergency solution would become the biggest military technological revolution in the last 50 years. Ukrainian technical universities, especially the Kyiv Polytechnic Institute and the National Aviation University, began collaborating directly with the Defense Ministry on rapid development projects. Aeronautical engineering students worked 24-hour shifts developing prototypes tested in the field in a matter of days. This brings us to the truly revolutionary part of our story. While traditional planes were becoming scarcer, a real industry of unmanned aerial vehicles was being born in Ukrainian garages. The numbers are simply staggering. Ukraine produced more than 2.5 million drones per year, with 1.2 million units delivered just in 2024, 96.3% of them manufactured domestically. To put this into perspective, we're talking about over 200,000 units per month, a production line that would make any smartphone manufacturer jealous. But we're not talking toys. These are real precision weapons. FPV kamikaze drones, FPV meaning first-person view, are aerial vehicles piloted in real time by the operator, who literally sees through the drone's eyes using special goggles. Each costs approximately $400 to produce and can destroy military equipment worth billions. The technology behind these devices is fascinating. Most use ultralight carbon fiber structures, high-efficiency brushless motors, and ultra-low latency video transmission systems. This means the operator can maneuver the drone with near-instant precision, even at distances up to 20 kilometers. The manufacturing process was completely decentralized. Unlike large traditional military equipment factories, Ukrainian production spread over hundreds of small workshops, tech startups, and even university student cooperatives. This decentralization was not just an economic philosophy, it was a strategic necessity. Small, scattered factories are much harder to attack and much faster to adapt to new needs. One of the most impressive innovations was the development of modular kits. Instead of producing complete drones, many workshops specialized in specific components: motors, flight controllers, camera systems, or explosive payloads. This allowed incredible flexibility. The same drone can be configured for reconnaissance, direct attack, or even as a communications relay, depending on mission. Development times were revolutionary as well. While traditional military projects take years or decades from design to deployment, Ukrainian drones go from initial concept to battlefield in a matter of weeks. Prototypes are tested in computer simulators, then in controlled flights, and finally in real combat conditions, all within less than a month. As technology evolved, Ukrainian drones began gaining longer endurance. This is where long-range aerial vehicles come into play, capable of striking targets hundreds or even thousands of kilometers away. The Bayraktar TB2, developed by Turkish company Baykar, was one of the first mid-range systems to be widely used. With the capacity to fly for up to 27 continuous hours at altitudes above 7,000 meters, this equipment covers impressive distances. Ukraine began operating American F-16s in August 2024, supplied by Denmark, the Netherlands, Belgium, and Norway, but it was the combination with long-range drones that really changed the game. However, the real innovation came with 100% Ukrainian projects. Drones like the adapted A-22 Foxbat, based on civilian ultralight aircraft, can carry loads up to 250 kilograms and fly over 1,000 kilometers. These devices are fascinating hybrids, combining the simplicity of a sport aircraft with state-of-the-art navigation and attack systems. The use strategy for these drones also evolved dramatically. Instead of isolated strikes, Ukrainian military developed the concept of swarm attacks. Dozens of drones launched simultaneously from different points, converging on multiple targets in a specific region. This tactic completely overloads conventional defense systems, which simply can't intercept so many small, fast targets at once. A recent attack used 117 kamikaze drones simultaneously, hitting air bases thousands of kilometers away. Imagine the logistical and technical complexity needed to coordinate such an operation. It's like a military symphony performed by hundreds of conductors working in perfect harmony. The scariest part of this technological revolution is the implementation of embedded artificial intelligence in Ukrainian drones. We're not talking about a simple command system, but real systems operating right now. Modern Ukrainian drones carry small computers equipped with AI-specialized processors, capable of making real-time decisions without human intervention. How does this work in practice? The systems use neural networks trained with thousands of hours of battlefield video. These intelligences learn to distinguish between civilian and military vehicles, identify movement patterns indicating threats, and even predict escape routes of moving targets. A real example from 2024 perfectly illustrates this capability. A Ukrainian reconnaissance drone was sent on an automatic patrol mission in a specific region. During the flight, its AI system detected thermal anomalies indicating camouflaged military equipment. The drone not only mapped the positions, but also calculated the most efficient approach routes for future attacks, all completely autonomously. This autonomy brings huge advantages. It drastically reduces reaction time, eliminates human errors caused by fatigue or stress, and allows continuous 24-hour operations. Ukrainian military developed the concept of clock missions, uninterrupted patrols, where drones automatically take turns, maintaining constant surveillance over specific areas. But perhaps the most impressive is the collective learning ability. Data collected by each drone is sent to a central network, where machine learning algorithms constantly refine and improve the entire fleet's capabilities. It's like every mission makes all drones a little smarter. This technology is being developed not only by large companies, but also by teams of university students and programmers working in tech cooperatives. After all this conflict, 2024 marked a new chapter in Ukrainian military aviation history. After years of negotiations and intensive training, the first American F F-16 fighters arrived in the country, supplied by a NATO coalition. But here's the crucial point. These fighters didn't arrive to replace the drone revolution. They came to work alongside it. The integration between traditional manned aircraft and swarms of unmanned aerial vehicles created a hybrid system much greater than the sum of its parts. The F-16s brought capabilities that drones simply can't offer: supersonic speed, heavy payload capacity, long-range radar systems, and most importantly, the ability to engage multiple aerial targets simultaneously. Additionally, Sweden supplied AWACS, Airborne Warning and Control System, ASC-890 aircraft, and is negotiating upgrades for Soviet-origin fighters still in use. Pilot training was intense and innovative. Instead of traditional conversion programs taking years, an accelerated system based on virtual reality simulators and artificial intelligence was developed. Experienced pilots in Soviet aircraft managed to transition to the F-16 in a matter of months, not years. Even more interesting was the adaptation of combat doctrine. Soviet-origin fighters still in use are being modernized to fire Western weapons like French-guided bombs ASM Hammer. This created a truly hybrid air force capable of operating equipment from 3 different technological generations in a coordinated way. The integration strategy is fascinating. The F-16s operate as central nodes in a broader network, coordinating attacks by hundreds of small drones while simultaneously engaging high-priority aerial threats. It's like having a conductor leading an orchestra where each musician is an autonomous weapon. What we're witnessing in Ukraine is not just a local adaptation to specific circumstances, it's a revolution redefining all military aviation worldwide. Currently, both Russia and Ukraine primarily use missiles and drones for deep strikes, with lethal air defenses on both sides creating a state of aerial parity. This represents a fundamental shift. For the first time in modern history, control of the airspace does not necessarily belong to the side with the most advanced fighters. The paradigm shift is radical. A PAC-3 interceptor missile from the Patriot system costs approximately $4 million. A Ukrainian kamikaze drone costs $400. With the price of a single interceptor missile, it's possible to build 10,000 attack drones. This math is forcing militaries worldwide to rethink fundamental air defense concepts. At the beginning of 2025, Ukraine was producing approximately 200,000 FPV drones per month, a number that keeps growing. This mass production capacity, combined with ultra-low costs per unit, is creating a new air power model based on volume, not just technological sophistication. The global impact is already visible. The United States launched the Replicator program focused on mass production of autonomous drones, directly inspired by the Ukrainian experience. China is investing heavily in AI-controlled swarm technologies. Israel, traditionally focused on high-tech, low-volume equipment, is reviewing its doctrines to incorporate volume saturation concepts. Most importantly, this revolution is democratizing air power. Countries that never dreamed of competing with superpowers in traditional military aviation can now develop significant capabilities with relatively modest investments. It's a geopolitical change of historic proportions. The story of Ukrainian air evolution is much more than a tale of adaptation in hard times. It's a window into the future of global military aviation. In less than a decade, a country went from the brink of total air collapse to global leadership in unmanned aerial vehicle innovation. The most important lesson is that limitation is not the end of the line, it's the beginning of innovation. When traditional resources run out, human creativity finds completely new paths. Ukraine proved it's possible to combine Soviet scrap, garage ingenuity, homemade artificial intelligence, and cutting-edge Western technology into a lethal symphony rewriting military manuals. Do you think this fusion of artificial intelligence, mass production, and human creativity will completely dominate the future of the skies? Or is there still room for traditional military aviation? If you like this video about how innovation can arise from most extreme limitations, leave your like, subscribe to the channel, and comment which of these technologies you think will have the biggest impact in the future. And remember, the future has already arrived. It's just not evenly distributed yet.